Welcome, everyone. My name is Tegan Clary. I'm the head of the marketing team here at Unchained Labs. I'll be your moderator today, and we really appreciate that you joined us today. At the end of this virtual seminar, we will have a Q&A session. So to ask questions, I know many of you know how to use Zoom, but just in case, there's a little Q&A button in the Zoom navigation bar. All you have to do is click on that on your screen, type in your question, and submit it. We do ask, if you can, try not to submit them anonymously so that we can either answer it live and or get back to you or follow up with you if we're not able to get to your question. We will try to get to as many of them as we can today. And now I'm excited about this webinar. I'd like to introduce Nellis Dennis, our market manager here at Unchained Labs. Hey, Nellis, how are you today?
Hey, I'm good. How are you?
Just in case everyone doesn't know, Nellis got a haircut this morning, so he looks fantastic. So I have to call that out. But Nellis is going to talk about our new stunner today. I couldn't be more excited about this. And he's going to take you through how it can characterize lipid nanoparticles like nothing else out there. So Nellis, not to steal your thunder, I'm going to hand it over to you now. And we'll dive right into it. I'll be back at the end to work through the questions with you. So take it away, Nellis.
Sounds good. Okay. Thanks again for that introduction, and thanks everyone for joining this virtual seminar. Stop guessing, get fast LNP quant and sizing on Stunner. Something as complex as an LNP comes with a lot of questions. There are a lot of properties that are important during development of your nanoparticles. What particle shape you want and what size they should have, which lipids or other components will be used and in which ratios, choosing your payload, and many, many more. Now, once your particle is made, even more questions pop up. Is my LNP actually the size I wanted it to have? How many particles do I have now? How much RNA do I have? Are there any aggregates? And again, many, many more things you want to know. All of these are critical to the performance of your successful drug. So when you've got lots of those buffers, formulations, and RNA constructs to test, you want to be gathering data on pretty much everything. But it requires a lot of characterization techniques to try to answer these. Until now. I'm pleased to introduce to you all Stunner, a one-of-a-kind instrument that lets you nail down your nanoparticle quality by knocking particle concentration, total RNA, size, detection of aggregates, all off your list in one shot. Without skipping a beat, you'll know if your nanoparticle is good to go. Stunner is the only system that pulls together UV-vis concentration, rotating angle dynamic light scattering, and multi-angle static light scattering on the same 2 microliter sample. So you just load your 2 microliter sample in a stunner plate. You don't have to bother with any sample prep or dilution or anything like that. You just load your sample as it is. And our consumable has a microfluidic circuit with 2 fixed path lengths built into it to cover a wide dynamic range. So if you're dealing with a full plate to fully characterize 96 samples, whether those are replicates or different batches altogether, Stunner will gather UV-vis data and all that light scattering result from 7 different angles, all in around 2 hours. Stunner's nanoparticle applications combine both technologies in a sample to deliver that total payload quantification, particle concentration, size, and PDI results. Not to forget, our consumable is SBS format, so it can easily be loaded with any liquid handling robot, or if you want to do full instrumentation handling, from loading to setting up an experiment to actually getting your results into LIMS, for example, all that can be easily automated. Now here we can see exactly what sample loading looks like with the help of some fluorescein and a black light. In 2 wells, you can see that there's already 2 microliter of sample loaded. Now, if we want to load another sample, you see that you simply add in that 2 microliter into that input well, and the sample wicks into the plate. After the plate is loaded into the instrument, the circuit is read first when it's still empty, and that will remove any absorbance contribution from the plastic. And then a pump applies a small vacuum which moves the sample into the microcuvette for actually being read. Because of our circuits have fixed path lengths, it can make very precise and accurate reads. Now, LNPs are larger particles, at least in the light scattering world. Now, this results in anisotropic light scattering, which means they don't scatter light the same in all directions. So if you're looking at overall intensity, it will change depending on which angle you're looking at. And on top of that, LNPs are often polydispersed, which will result in different sizing outputs, again, depending on the angle you're looking at. Stunner has the ability, as you can see here, to rotate its angle where it does DLS at. And so it gathers size and intensity data on your sample from 7 different angles. Now, the software will combine all of that information and give you one clear output, both on size and intensity, which is angle independent. So it doesn't matter how large or polydispersed your sample is, Stunner's Rattles technology has got you covered. So I've already mentioned that size and particle concentration are critical components to monitor for multiple reasons, like dosage or delivery efficiency, and many, many more. Stunner knows how many LNPs are in your sample by looking at all those different angles and giving you one clear output. So no matter how small or big your nanoparticles are, Stunner will pile up particle concentration for every peak size. Here we have a large and small LNP read by DLS, and we're looking at the size versus particle concentration. The area under the curve is what's quantified to figure out particles per ml. And so it becomes clear that for these samples, we have about 10-fold more small lipid nanoparticles than the large nanoparticle prep. In this next slide, we're looking at a log3 dilution series of a lipid nanoparticle prep, and Stunner can provide answers across that whole range. So don't worry with getting into a perfect range to get your results. Whatever batch or LNPs you are making, small or large, no matter what flow rate you use, Stunner can get you the answers you need on your actual stock samples, so you can quickly compare batches or formulations to each other and decide on next steps. So Stunner will provide all of the light scattering results you need, starting with the average hydrodynamic diameter and polydispersity index, but also an intensity, mass, and number weighted size distribution with a quantifiable area under the curve. So now you no longer have to be limited by DLS data that has to be manually gathered for about a dozen samples a day. Stunner allows you to measure 96 samples all at a time, so it can keep up with LNP samples as fast as you can make them, or running as many replicates as you want while giving you a full size distribution. And all of that allows you to also put your sizing data in context. We're looking at quantifiable intensity and mass distributions on 2 different LNP prep. And it's very hard to spot on this slide, but since the lines are almost perfectly overlapping, but both these preps are run in triplicate. By not using normalized distributions, but quantitative ones, and by having the option to run up to 96 samples in one experiment, you can easily compare replicates and run all the statistics you want on that, or compare different batches directly to each other. Okay, I've already shortly mentioned that after a good 2 hours, you'll get all the results on 96 samples, both the UV-Vis results and the light scattering results from 7 different angles. Now that is all measurement time. Actually, hands-on time is about 10 minutes to load your plate, since you just load that 2 microliter of stock sample into our consumable without any sample prep or anything else. While other classic light scattering instruments will be one by one, resulting in more than 3 hours actual hands-on time to get the same amount of light scattering information on 96 samples. Okay, that was all about light scattering. Let's shift to RNA quantification. The most famous product with nanoparticles is for sure the mRNA vaccines. Now, the important factor here is, of course, the dose. Dye-based quantification is multi-step. It requires dilutions. It uses costly standards and dyes, and it requires hours of analysis and hands-on lab work. It also includes breaking down that precious particle you just made, all to get some information on your RNA concentration. There needs to be a better way. But LNPs are typically very turbid, cloudy samples, and so you could try to quant with UV-Vis, but nanoparticles nanoparticle solutions have so much turbidity in them that they block most of the light, so traditional UV-vis approaches fail. Until Stunner. Here we're seeing an LNP sample in our cuvettes. To read the plate, the Stunner will pump the sample in the two fixed pad lengths, which are 0.1 and 0.7 millimeter in height, for doing that UV-vis absorbance measurement. And because of these short path lengths, light can actually still pass through even though you have cloudy nanoparticle solutions and enable an absorbance measurement. But we're not there yet. Light can still pass through and we can get an absorbance spectrum, but LNPs create a whole lot of signal that looks like absorbance, but it's actually turbidity from all the different particles. And that's usually not helpful at all and just gets in the way for you to actually analyze what you want to know, your RNA concentration. And so because of all that turbidity, making classic traditional UV-vis almost impossible, even if you have a microvolume system, total RNA quant by UV-vis is just a big challenge. For example, if we squint at the full curve, you'll see that there's a small bump at about 260 nanometers, which is the absorbance of your RNA. But if you would want to get an actual reading out of that on even the microvolume classic UV-vis system, you would need to be able to blank with almost the exact same amount of empty nanoparticles, which is frankly impossible to do. And that is why cloudy solutions of LNPs and any other nanoparticles hang up other UV-vis technologies. But because of Stunner's short UV-vis path lengths that allow the light to go through, in combination with our unmixed algorithms, you'll get the answers you need. Stunner knows what different components you have in your sample and will deconvolute the measured spectrum, cut through all that turbidity, and report out your absorbance signal from your payload, RNA in this case. So Stunner's crazy simple quantification frees you from those complicated disruption workflows with those costly dyes, wasteful standard curve to give you that RNA concentration. And we already talked about how complex LNPs are and how that results in a lot of room for optimization. Now, researchers are trying to improve targeting in many forms, passively by playing with size and composition and such, but also actively by adding on targeting ligands like antibodies or antibody fragments or other options. While we just went over characterizing LNPs on their own, the basic RNA LNP is already very difficult. Characterizing antibody LNP conjugates is even harder. How would you get an RNA concentration and antibody concentration, their ratio, and all of that other stuff you want to know by using a method without just spending days and days in the lab? Well, Stunner's unmix allows you to specify two spectra that you want to quantify. So here we're looking at an RNA LNP with IgG spiked in. By defining that this sample has IgG and RNA, and of course our normal components, the lipid, the buffers, and the turbidity, Stunner will deconvolute the measured spectrum and output RNA concentration, but also protein concentration, their molar ratios, alongside your particle concentration size and all the data you might need, all on that same 2 microliter sample, making it so much easier to optimize your product so it can easily reach its targeting. So quant exactly like you want. Using riboguine to quantify your RNA means you'll need to lyse your particles, means you need to use 2 standard curves with costly standards. Basically, to measure 4 samples, you'll end up measuring 96, including all the standards and controls. While doing 4 samples on Stunner is simple. Dye and standard free, no lysis is needed. You'll get RNA concentration and all the rest, size, particle concentration, everything we just mentioned, on those 4 samples in less than 6 minutes. And we have IQOQ procedures available, and Stunner software can be made 21 CFR Part 11 compliant with full audit trail and electronic signature capabilities and data integrity. For labs doing manufacturing, quality assurance, quality control, Stunner has a performance verification. These tests meet the United States Pharmacopoeia and the European Pharmacopoeia guidelines for UV-Vis systems. The tests and all necessary calculations are handled fully automatically by the software. So with Stunner, you'll be able to generate so much results so quickly that you can go crazy with making LNPs. And this is where I also want to introduce you to Sunscreen. With 96 well plates for your reagents and collected samples, and full automation once your experiments are running, you really can crank out large numbers of LNP formulations like never before. The system will use driving fluids to move your precious sample around the system and mix them together, meaning you can use as little as 200 microliter per experiment, and that will overall keep the cost of your experiment low. By keeping the cost low, you can make hundreds and hundreds of formulations and still remain within your budget. Next to that, Sunscreen has a reusable microfluidic, and it allows you to scale up to continuous manufacturing with the same method. So Sunscreen really is one of a kind when it comes to formulation screening. So Sunscreen was used to produce a range of LNPs at different total flow rates from 6 to 12 milliliters per minute, and samples were characterized on Stunner. As the total flow rate increased, the mean diameter of your LNPs steadily decreased, which is expected as higher total flow rates correspond with the increased shear rates during mixing. For this screen at constant lipid concentrations and flow rate ratios, the smaller LNP diameters formed at higher total flow rates also correlate with higher concentration of particles. Total flow rate did not correlate with RNA concentration, which again is expected as long as we keep the flow rate ratio and the concentration of RNA in the aqueous phase both constant. And then lastly, with constant RNA concentrations and higher particle concentrations, Stunner calculates the number of RNA molecules from your RNA concentration and will give you an average RNA molecule per particle output, here shown in the loading graph, as a way to easily visualize the impact of different LNP formulations and process conditions. So make as many LNPs as you want. Stunner will dish out all you need to know about your LNP by combining that UV-Vis and rotating angle dynamic light scattering to get you your size, your RNA concentration, your particle concentration, and an average amount of RNA molecules per particle. So walk away from one-by-one single-angle DLS that requires hefty hands-on time and has no way to bridge your data from DLS to your concentration data. Stunner always tells the whole nanoparticle story by giving you label-free, standard-free, and hassle-free nanoparticle characterization, all from just 2 microliter in less than 2 minutes. Thank you all for listening to that, and I'll take any questions now.
Yeah. Hey, Nellis, thanks for taking us through how Stunner can measure not just the size, but now particle concentration, the payload, loading, and frankly, aggregation if it's there. We know that a lot of scientists are working on a lot of novel formulations, lots of different kinds of payloads. And so I think, with the combination of our microfluidic LNP Sunny Suite products and helping people make LNPs, they now have a perfect match for the analytics coming off those systems so they can characterize a lot of samples quickly. So thanks for taking us through that. We have some good questions, so let's go ahead and dive right into those, and we'll hit them in order, okay? So from earlier in the presentation, there's a question: is this a benchtop instrument? Is it big? Is it small? What does it look like, Nellis?
It's about like 30 kilograms, and then it nicely fits on a bench. So yeah, microwave size, I would say.
Microwave size, that's perfect. Okay, next question. How many measurements and how much sample do I need to get all those outputs that you talked about, all the measurements of an LNP?
So that's one of the nice things. You basically load at 2 microliter, and everything we talked about, that's all from the same exact measurement. So you load that 2 microliter and you get all of those outputs from it. You don't need to set up 4 or 5 different measurements for it.
Okay, and then I think a common thing people are looking for and want to measure is encapsulation efficiency, right? Of LNP formulations. Are they able to measure that directly on Stunner, or can Stunner help with that in any way?
Yeah, so our UV-Vis will give you a total RNA quantification. So to do the full encapsulation efficiency, we can't provide that. But it is an easy way to get your total RNA. And we already have customers using that as part of their calculation for encapsulation efficiency. So you only need to do the free mRNA part of your calculation, and then you use the total RNA part of Stunner to get your encapsulation efficiency. So you skip the whole lysis step and the extra standard curve and all of that. So it really helps minimize the work there.
Yeah, so that's just time, material, and cost, right? That you can eliminate a big chunk of that. So yeah. Someone said they don't use mRNA as a payload. Can they still use Stunner to do some of the same work or same analytics?
Yeah, so that's one of the great things. This is not nucleic acid specific at all. So anything that absorbs, we can quantify. And so whatever your payload is, that might be RNA, DNA, protein, or whatever custom thing you want to put in there, as long as it absorbs, we can measure it.
Okay, great. Another one is Stunner compatible? I'm going to add part to this, but I think this is a common question we get asked. Is Stunner compatible with LIMS? And is it automation compatible? Is there a way to make that work either, physically, virtually?
Yes, so you can in standalone motors, you can just specify your report, what you want in there, and in which order, and save that. And so it's always exactly the same. That's going to be in CSV, for example, so it can easily go to your LIMS or whatever lab management software you have. And if you want to go full integration mode, this can nicely fit in robotics and then do everything full automatically through the driver, through any integration software, and therefore also go to your LIMS directly.
Yeah, and I know you've helped many people do that, actually set that up with our systems, both Lunatic and Stunner. So if somebody's interested in that, Nellis is our guy. So okay, next one here, Nellis. How do we calculate particle concentration with Stunner and the RNA per particle? Can you just hit on that one more time? I think somebody has a question about that.
Yes, so there's one way per peak. Basically, we gather intensity and size distribution from that. And I'm happy to share this afterwards, but some calculations can get you from intensity to a number distribution. And then our size distributions are quantifiable. So the area under the curve is going to be your peak particle concentration. There's a second method that allows you to get a particle concentration from total intensity as well. But again, happy to explain that all later on. And then I think it was RNA per particle. Basically, we measure RNA concentration. Our software is so easy set up, so you also have an input on molecular weight of your RNA, for example, and then it can calculate what that concentration means in actual molecules. And so you can define that RNA molecules per particle, which is a basic output from the application.
Right. And then just to really make this clear, because there are a couple of questions in here about, right, it says this question was, how can it identify free mRNA versus LNP encapsulated mRNA? And
yeah, so
let's make sure we're clear on that. Okay.
Yeah, so we can't. We see the total amount of RNA in your sample, but with any output you get there, it can help you figure that out, combined with ribogreen, for example.
Okay, and then some more. We got a bunch now. So is it possible to measure both size and concentration in a single loaded sample, or do they have to be loaded separately? I think that's a question we get commonly too. So
yeah, so you load your sample, it goes into those two micro cuvettes. We'll read the UV-Vis part first, and then on the largest cuvette, we'll do all the dynamic light scattering. So it's a single loaded sample. All that output comes from that 1-2 microliter. That really makes it very cost beneficial, I would say.
Right. Okay. And then is it possible to reuse a plate after you've measured it says the first 10 samples? So like, can you run some and then set it aside and come back and use the rest? Let everybody know how the plate works. I think that's
Yeah. So you can run from 1 sample to 96 on a plate as much as you define, and then afterwards you can use the rest. So in this case, you use 10, you can use the other 86 the next day or in an hour or anything like that. The only thing you can't do is reuse a position that was used before.
okay. And then some people probably know Stunner has an application for empty full for AAVs. And I think there's a question here. Can we do like an empty full ratio of LNPs is the question.
Well, again, we can't see if it's encapsulated or not, but that's a bit what I was talking about, the loaded. You now have a way to know your RNA concentration and as well your total particle concentration. So at least you have an idea of how many RNA molecules in total you have in your sample. You have an idea on your total particle concentration, and the software actually combines that. So you can really optimize your process to get to what you want to.
Okay. And then I think you get asked this a lot. Can it be used for other types of nanoparticles? Is there any reason somebody can't measure a different type of nanoparticle other than an LNP?
Yeah, that should work. I would say reach out. We're happy to explain what we can do there. But yes, there's no limitation to what particle it is. So for example, if you build one purely from proteins and you add some nucleic acids to that, that won't be an issue at all.
Okay. And then there's 3 more. This one's is a little long, so I'll try to hit this carefully. But it says, do you have data to compare the total RNA output calculated by Stunner compared to the RiboGreen calculation? So, I think what you were mentioning is you can do Stunner and then do only part of the RiboGreen assay to get the answers. So can you just maybe tell everybody how we've looked at that as compared to the standard way of doing that?
Yes. Well, basically, a lot of people put a lot of different things in their nanoparticles. So I would always say validate first. But once you've done that, you can definitely replace. So we've seen that on different types of RNA, small interfering one, polyase, anything like that. So my main answer would be validate first, and then you can sorry, my English is blocking you. Confidently replace that part of it.
Okay, great. A couple of other things here, Nellis. Can someone read samples with some ethanol in the solution? Do they have to dialyze it first? Will it be a problem, or is it not a problem?
So up until 20% ethanol, it won't be a problem at all. You can just read as is. If it's above that, let's say 40 to make the calculations easy, I would say make a 1/2 dilution, and then you should be able to get your results.
Okay. So in some cases straight up, in some cases just a quick dilution. Yeah, right. And then just a question about the instrument. How often does Stunner need to be cleaned or calibrated? Like what's maintenance look like on a Stunner for people?
Oh, that's fairly easy. There's a calibration plate with the instrument for general hardware settings, which takes about 10-15 minutes. And next to that, there's a size and intensity verification check. I would say do that quarterly or every single time you would move the instrument or anything like that. But other than that, there's no calibrations or anything in there. So that's a nice thing about these technologies.
Okay. And I think when we talk about multiple angle, or in our case, rotating angle dynamic light scattering, this question comes up a lot. This is the last one, but and it came up at the Pep Talk conference actually yesterday. Can the system give a kind of an indication or some information about the spheric particles or particle shape? And I know this is something our team's been super interested in, but can it do anything related to showing kind of whether it's spherical or not spherical or shape?
Yes. Well, with doing the multi-angle light scattering as well, so getting static light scattering from 7 angles, you can also get RG information, and so that is an indication of shape as well. So RG over RH, where the center of mass is compared to the center of your particle. So yes, with our rotating angle system, giving you all that different information that is an indication you would get.
Okay, great. Well, that was the perfect amount of questions for Nellis. So I just want to thank all of you for spending 30 minutes of your day with us. And Nellis, thanks for a great presentation and for getting through all of those good questions. If anyone out there wants to have a deeper conversation with Nellis or anyone else at Unchained Labs about Stunner and how it can help you with the characterization of your lipid nanoparticles or your other nanoparticles, all you have to do is go to info@unchainedlabs.com. Just send us a note, say, hey, I was at that webinar. I want to talk to somebody more about it. Please do that. You can also go to unchainedlabs.com and go look for Stunner. It should be really easy to find and take a closer look. And then again, get in touch with us if you're interested in learning more or diving further into it. So thanks for attending. And Nellis, again, thanks. And I hope everybody has a great rest of your day.